If you're a 3D printing enthusiast or just getting started, you've probably wondered about the differences among the wide variety of filaments on the market. Below is an introduction to the most common 3D printing filaments. First, let's talk about FDM filaments. These are thermoplastic filaments, typically with diameters of 1.75 mm or 2.85 mm. They are melted by heat and deposited layer by layer to form a model. 1. PLA. Advantages: made from plant starch, eco-friendly, non-toxic, and biodegradable. Low printing temperature, very beginner-friendly with a high success rate. Smooth, fine surface finish with rich color options. Low cost. Disadvantages: poor heat resistance, softens above 60 C and cannot contact hot water, radiators, or other heat sources. Brittle at low temperatures, prone to cracking in winter or outdoor use. Limited long-term stability, affected by light and humidity, tends to age, become brittle, or delaminate after 1 to 2 years of storage. Low mechanical strength, weak tensile and impact resistance, unsuitable for functional parts. Applications: models, figurines, toys, decorative items, and one-time display pieces. 2. ABS. Advantages: engineering plastic with solid mechanical properties, high strength and impact resistance, does not easily deform or soften at room temperature, can briefly withstand hot water or heat sources up to about 100 C, suitable for load-bearing functional parts, higher surface hardness than PLA, less prone to scratching during long-term use, can be post-processed sanding, drilling, etc. Disadvantages: high shrinkage rate about to 4, prone to warping, corner lift, or bottom cracking, requires an enclosed printer and temperature control, emits irritating odors during printing and releases trace amounts of styrene, requires good ventilation and is unsuitable for small enclosed spaces. Hygroscopic, moisture can cause bubbles during printing, reduced toughness at low temperatures, becomes brittle below -10 C. Outdoor use may lead to aging and yellowing. Applications: small gears, mechanical brackets, household parts, appliance components, tool housings, and other functional parts. 3. PETG. Advantages: excellent all-around performance, combines PLA's ease of printing with ABS-like toughness, usually does not require an enclosure and rarely warps. Good chemical resistance, can contact alcohol, weak acids or alkalis, and common household cleaners. Complies with FDA food contact safety standards. Transparent versions offer up to 80% light transmittance. Suitable for lampshades. Good stability, resistant to aging and yellowing, with a shelf life of over 3 years when stored away from light. Strong layer adhesion, parts are less prone to delamination. Disadvantages: slightly weaker fine detail performance, high flowability when molten. Details below 0.1 mm may appear blurry. Surface tends to attract dust. High-speed printing is challenging. Speeds above 50 mm per second often cause stringing and require careful tuning. Moderate heat resistance, softens at 70-80 C and cannot withstand long-term exposure above 80 C. Applications: snack containers, lampshades, storage boxes, and other daily use items. 4. TPU-TP. Advantages: excellent flexibility, sure hardness typically 50 to 95 A, can bend, stretch, compress, and rebound. Rubber-like feel with good shock absorption and sealing performance. Ideal for phone cases, insoles, sealing rings, flexible toys, and elastic parts. No additional post-processing required after printing. Disadvantages: difficult to print. Soft material deforms easily and may slip during feeding. High-speed printing can cause stringing or nozzle jams. Recommended speed is 20-40 mm per second. Thin walls and fine structures may collapse. Visible surface texture, not as smooth as PLA. Easily stained by oil and grease. Ages easily at high temperatures. Softens and becomes sticky above 80 C. There are also engineering-grade filaments such as nylon, PC, and ASA, which offer high heat resistance and mechanical strength. Nylon can approach metal-like strength but requires advanced printers and is more difficult to print. Composite filaments are made by adding fillers to base materials, carbon fiber which increases stiffness and strength but accelerates nozzle wear. A hardened steel nozzle is recommended. Glass fiber which improves heat resistance.
Wood-filled, which produces a natural wood grain appearance. Metal-filled, contains metal powders and can be polished after printing to resemble metal.
Filament suffixes also have specific meanings. Plus or plus, reinforced version with improved toughness and durability. Pro, professionally optimized for better stability. H is designed for high-speed printing with smooth flow. HT, high temperature grade with a higher softening point. FR, flame retardant. Est, electrostatic discharge and static, silk, silky, glossy finish. Matte, matte finish. Glow, glow in the dark. There is no absolutely good or bad 3D printing filament, only whether it is suitable for your needs. For beginners, PLA is ideal for practice. PET works well for everyday containers. TPU is the go-to choice for flexible parts. ABS is suitable for outdoor or functional items. And for high-strength requirements, consider engineering-grade or composite filaments. The wide variety of filaments makes 3D printing more fun and versatile. By choosing the right material based on your needs and its properties, you can achieve better results. When printing issues arise, reviewing the filament's characteristics often helps you solve problems quickly. Hope this video helps, and don't forget to like, save, and follow.